And there we go. Hello, everyone, and welcome to a sleepy morning edition of Handmade Hero. We are getting started late today because, honestly, I was just too tired. So I was drinking my coffee, and we were chatting while trying to get to the point where our brains might actually function to do some programming, because we do have some programming to do today, and it is not the absolutely trivial variety. We are going to go in and modify our stand-in collision detection loop to do some new stuff that we wanted to do in terms of working with entities that define the walkable regions and the ground in the game. And of course, the reason we're doing this is because we want to be able to have rich three-dimensional constructions in our game. Even though it is a 2D game, we want to be able to do things like rooms on top of rooms that you can see down into other rooms from, and ledges you can jump off of and land on lower ones. Again, this is not necessarily because we feel like this is crucial to the game design or anything like that. As is typical on Handmade Hero, it's more about making sure that we don't shy away from solving the harder problems in any particular game space. And so the fact that this is something that is raised by the type of game, I want to tackle it head on and show everyone how to tackle these kinds of problems. Even if we, in the end, don't really decide to use it very heavily in the actual game design, we still want to make sure that our engine tech is, top notch. And I feel like this is the kind of thing that, if I were looking at some kind of a 2D engine licensable thing, right, I want to know that it's got a really nice, robust system that allows me to define these nice 3D things, even in my 2D game, so that it all works kind of seamlessly and feels good and doesn't have janky corner cases, where as a designer, when I'm making my game in it, I gotta be like, oh, I gotta hack all this stuff in and add all these other special checks to sort of approximate the fact that it's gonna be in 3D, right? So we kind of talked about this yesterday. I highly recommend watching yesterday's stream before this one if you haven't already, because we kind of talked about exactly what we wanted to do as our first attempt at solving some of the ground specification problems, because it's a little bit of an open-ended sort of thing, since there's a lot of ways you could imagine doing it, and there's questions about, what do you think would be the most effective. And so I'm just going to go ahead and start programming the stuff that we said we were going to program yesterday. We added all of the infrastructure we needed to do that, but we haven't actually done the computation on it yet. And so that's what we're going to be doing today, is writing that computation and then playing around with it to see if it does what we need it to do. So with that in mind, I will just remind everyone that if you wanted to follow along with the source code and you have pre-ordered the game, today is day 80, which is our second week of programming, right? 1 hour a day, 80 hours, that's 2 40-hour work weeks. We are finishing up our second full week of programming. Very exciting here on Handmade Hero. But that means that if you have that source code zip, you want to unpack day 79 out of it, because that is the source code that I'm starting with now. And so let's see how sleepy we actually are. Let's go ahead and bring up those collision detection routines and see if we just stare at them blankly, going, I don't know what all these letters and numbers on the screen mean, or whether we actually, whether the coffee has kicked in to the point where we actually can write some code that makes sense. All right. So the first thing that I'm going to do is take a look at, sort of doing an as simple as possible modification of the loop. Because again, we'll probably do some significant upgrades to this collision loop in terms of robustness and performance and everything else. So we don't really care necessarily how efficient this loop is right now. As long as we think we can make it efficient later, that's fine. So really what we want to do here is take a look at this loop and go, well, looking at this loop, what can we do to sort of tackle this thing we were talking about yesterday, which is this right here, right? We want to turn our loop that was looping on one type of t value to something that loops on two type of t values. We want to say, all right, find the minimum t that is where we would stop if we were going to hit solid entities. That's what we're already doing. Let's augment this loop to also have a second t value, which is the maximum distance you could go in the entities that are representing entity space, right? So we're doing our own kind of constructive solid geometry here, merging things together. So that's what we're doing. And that means we've got to sort of upgrade this t handling. So if you look here on each iteration of the loop, you can see that we've got the tmin, and that tmin is exactly what we were working with in terms of entities getting hit. So what we want to do is introduce another one here, I think, tmax, which is saying this is how far you could go maximally. And obviously at the outset, tmax is going to be equal to 0 because at the outset of a loop, we have no idea how far you could go before hitting a boundary of one of these solid objects. And so if you know, I thought of something else we're probably going to have to add for this. And it's something that's pretty good to talk about, so that's good. But anyway, we'll get to that in a second. And so what we want to do is we want to look at the entities now, and obviously we've got some that are operating on tmin already, and that's good. That's exactly what we want. But what we want to do now is also take a look at entities that would affect our tmax. So we do can collide, and we go through and you know, check the things that we collide against. And in fact, I think we probably want to move this inside. This is an interesting early out, I guess. But for now, I guess let's go ahead and just and just do this here. So we're going to go ahead and add that can collide on the inside. So after we start looping through the volumes, and we're going to do a volume check, I guess the way that I would say it is when we, well, no, you know what? Let's make 2 checks here, because we sort of have two kinds. This is like our early out, if you will, right? It's our thing that says, do we need to do any checking on this guy at all? And it feels like we probably want to leave something like that in place. So I guess we'll actually just do 2 checks, right? We'll see whether there's any kind of collision that's going to happen here at all. And then we also need to say later what kind of collision that actually is. So when we go through this, what we would say is, all right, if it's something that we can collide with in some way, then we go ahead and set up the collision computation. When we do the collision computation, we then actually want to do these tests differently, right? So right now what we're doing is we're testing the 4 walls of the bounding box for whatever the entity is. We want to go ahead and do this so that instead of looking for the minimum t, it's going to look for the maximum t. And I feel like probably the easiest way to write that right now is to have test wall compute both. And then at the end, we will just do whichever one is, you know, whichever one is the one we actually wanted to pick. Now the problem with that is the test wall normal stuff, that's going to be a little janky because we don't actually know, we need to know which of the two, whether tmin test or tmax test, which one was hit potentially, I guess. No, that's not true. That's not true, I suppose. Well, you know, I mean, this is what I'm thinking. We have this test wall call, and inside the test wall call, right? I'm just trying to think of how to structure this the most effectively. Inside the test wall call, what we're doing is we're checking to see whether or not the hit was earlier than it used to be, right? In fact, you know, this is that test right there, right? Saying if this test is earlier, then we're going to accept it. And if we want to add a thing here that says if this test was larger than a tmax, accept it for the tmax hit as well. So again, I don't know. It seems like to me almost that we want to actually just have 2 different loops here, which is kind of annoying to say the least, but I don't know. I mean, you know, maybe that's just what has to happen. So, you know, it would look something like this if we were to do it that way, right? It would look something like this. where we have one of them here and we have exactly the same code duplicated for the max on the other side. Now, I feel like that's a little bit ugly, so I'm wondering too if maybe we wouldn't turn this into something that just loops over data, right? Which seems kind of plausible. Maybe I'll give that a shot first. So let's the way that I'm thinking about it is basically this this test wall, we've sort of manually made this a loop over data by repeating the code and then plugging the data in, right, in each individual case. And so what I could do is loft that into some actual data, right? And then just do a for I loop over it. And that would give me the opportunity to do that for I loop in two different ways without having it be particularly problematic, right? And again, since we don't super care about the performance of this routine at the moment, that is probably fine. We don't have to think too hard about it. So I'm kind of want to lean towards a thing that's going to be the easiest to type in. So let's try that, right? Let's go ahead and say, okay, if zero this out, seems like a good idea. If zero this out, and let's turn this into an actual for loop. So if we were going to turn this into a for loop, and it looks something like this, wall index equals 0, wall index is less than array count walls, something like this, wall index plus plus. And then we're just going to do this once. I guess that's technically up there. We're just going to do that, like so. And each wall, so I don't know what we'll call this, a test wall, I'm not sure. Each wall we will loop through, walls plus wall index, and we will just grab out of that all of these values that we were going to use previously, right? So we'll basically say, all right, yeah, we've got, the wall min corner x, so I guess let's just do that. The wall relative, what are these actually? In fact, they're just these. So, it'd be this, right? So there we go. We'd get rid of tmin, but everything else would just be in there. And so the test wall is just wall x, wall, I guess this is, wall x, wall rel x, wall rel y, wall player delta x, wall player delta y, and maybe I'll just change those to be calling delta x and delta y, so on. And then got the min y and the max y, right? And so we'll call that test wall function like that. And now that allows us to data drive this, this call so that we can, and this is the exact same here, test wall normal would be equal to wall normal. That allows me to just build a data structure that will allow this loop to drive, and then we don't have this code spammed out here. So if we want to duplicate this loop twice, it's not such a big deal, right? So that also allows me to move this inside, potentially, since we want to do this check two different ways, one with a min confirmation and one with a max confirmation. So I'm going to go ahead and do that as well, although I guess I'll do it in 2 steps to make debugging a little bit easier. So let's go ahead and now turn this into data. So we now want to take all of these things that used to be actually spammed out as individual calls here and make them into data, right? Like so. So here's all my values minus the min test. So that's gone, right? And I guess I think I accidentally removed that entirely. So in here, after that delta y, we do need tmin to be here. So we want tmin test to be in there as well. So there we go. So that's really all I'm talking about here, right? I guess we need that wall normal as well. So let's grab that and stick that in there. So now we've got an easy way to data drive this. And that's a good technique, especially in situations like this where, our primary concern here is not the performance right now. So we don't really have to worry too much about how we structure this. We just want to make sure we structure it in a way that's reasonable and more or less easy for us to modify right now. And then we can kind of go through later, once everything's said and done and we're in a more performance-oriented mindset, we can sort of attack this later on, because obviously there's no difference between these two things. If later we needed to pull this back out into some more explicit code, we could always do that. So, all right. So there's our fault for walls, and here's our wall testing. And honestly, I think that may just work. All we need to do now is actually define this test wall, and that's going to be exactly this stuff, right? Like so. So we have our x, we have our rel x, we have our rel y, we have our delta x, we have our delta y, we have our min and max, and that's it. We have too many. Oh, right, and we need to remember our normal, which is not something that's actually being passed. So that's actually our normal. There we go. And so let's make sure that that is still working at all, right? So that appears to be working just fine. So that's all good. No problems there. All right, and yeah, everything's still good. We can walk through things. Perfect. So let's take this the next step further. Let's move test wall into there so that we're not actually calling it anymore, so that we actually just have this called directly embedded. So what that's going to look like, right, is this. So inside here, we're going to actually do this case inside here, right? That's what we were doing before. We're going to get rid of all of this. And we can actually loft some things out pretty trivially here. I guess all we really need to do is just make these operate off of that pointer, right? So I'm just going to go ahead and do that. So all of the wall stuff is this way. There we go. And t_result is just a thing we computed, and then tmin is this guy right here. All right, so this is tmin test, right? Like so. And we don't have to do pointers to it anymore. We can just use the actual value. So tmin test like so. I think that's most of what we need to do there. So there's our wall. There and there. And that looks good. So let's see. Okay. So now we've basically collapsed all that down into a little loop. It looks pretty nice. So here we go, and that all seems to still work pretty good. Go out here, test against all these guys. Everything looks good. Yeah, so pretty happy with that. Can we still shoot? Oh man, did we break our hit testing for against the Monstar? I feel like we did, right? It's not doing that anymore. I wonder, that doesn't have anything to do with what we were doing, does it? We just didn't test that in a while. Double check. Yeah, so we got a bug there we should take a look at. Someone remind me to take a look at that. It doesn't really matter at this point because, like I said, we're still playing with all this stuff, but we should. It probably has something to do with the fact that we have changed the 3D-ness of everything, and maybe that sword no longer overlaps the guy when it passes through or something like that. But all right, ignoring that, moving on. So what we want to do here is also have something where we test, in entities that we would consider inside entities, like those empty space entities. We want to do this testing a little bit differently. So we would basically say, if we're testing for an inside entity, we do this, right? And if we're testing for an opaque one, we do this other thing, right? So let's go ahead and introduce a second loop here that we're going to do for things that are inside entities. And that would be, that would be a double if actually, because we have to see, we only do it for things that we're currently inside. If I think about it correctly, right? You want to find the maximum t for the empty space entities that you're actually inside. So here's that secondary type of test. And really the difference here is that instead of tmin test, we're going to be using tmax test. So this is tmax test. This is tmax test. like so. If we were doing it this way, we need to reverse the sense of these. So basically, we want to make sure that whatever the result is greater than 0, and then we want to say, all right, whatever, excuse me, whatever this max is, we want to accept it any time that the Tmax test is less than the T result. So if we were going to have a hit that was further away now, before we were testing for hits that were closer, now we want to test for hits that are further away than the best one we've got so far. And then when we come in here, I don't know what we would want to do epsilon-wise. The reason we had epsilons before is to stop you a little bit before you got to the wall. And in this particular case, I don't know how much we care about that exactly. We do have a bit of a problem, which is you are never allowed to be outside of these. And so I feel like, you know, probably what we want to do is we want to stop you exactly on one and perhaps do, you know, like a fix-up afterwards to make sure that you're always inside, right? We want to keep you constrained to the outside, to the inside of these as much as possible. So for now, we're just going to say that this is going to be T result, like so. We've already tested it against 0, so we know it's not a hit that's behind us, so that seems fine. And test wall normal, in this case, we have 2 of these, so we're going to have a test wall normal on the min side and a test wall normal on the max side, right? We want to track both of those, so we have test wall normal min and max, and we've got our T-min test, and we've got our T-max test, which I guess is just 0, yeah, to start with. So there we go. We come through here. We do our Tmax test. We now have that computed. And so at the end of this, we actually know both of these. I suppose for these 2 things, I don't really know exactly what we want to do. It's a good question in terms of these guys. I suppose for now, let's do this handling separately since it's going to be pretty different probably. So this is the case where we were, you know, hitting something that was going to stop us. This is the case where we're hitting something that isn't going to stop us, that's allowing us to move. So assuming that we hit it, we now would say, well, we don't need to do the speculative collision stuff probably. We do need to say that our hit wall normal max is equal to our test wall normal max. Our hit entity max is going to be equal to our test entity, and our Tmax is going to be Tmax test, right? And similarly, our wall normal min here is going to be equal to our test wall normal min. Now, I guess technically, so since we only do one of these loops, I suppose we actually don't need to do, we don't need to have 2 test sets, right? Since we can get rid of this, right, this is gone. This could really, we could just leave it as test wall normal, right? And in fact, this guy goes inside the secondary loop. So we could just say, all right, test wall normal, that's just going to be test wall normal, right? No big deal, test wall normal, test wall normal. And this guy can do it the same way. So it's really only that outer one that actually needs to be specified as both the min and the max. All right, so we got test wall normal min, test wall normal max, like so. And at the end, now we just have to do some thinking about what's actually going to happen depending on which one of the this is. And oh, right, I needed the hit entity min and max as well. So that comes up here as hit entity min and hit entity max. So I guess what we'd want to do now is we want to see which of our T-mins was sooner, right? So what we want to do is say something like, you know, pick one here. So we want to say if our T-min is less than our T-max, that means that we hit somebody who was opaque and he stopped us, right? A solid entity stopped us from moving. So if that's the case, then what we would like to do is we want to introduce here, because tmin is going to be used to compute the actual motion, we want to introduce a thing here which is tstop, something like that, right? And so our tstop is something that we're going to initialize depending on which side of this we take, right? Like that. So if the tmin is less than the tmax, then the stopping value is the minimum, and if the tstop, if the other way around, then the tstop is whatever the maximum one we hit is, and that determines what our hit entity is. I guess we'll call it our stop entity. Well, no, our hit entity is fine, right? So our hit entity equals our hit entity min in this case, and our wall normal equals our wall normal min, right? Like so, max, max, max. And those things can now move down, I believe, meaning that, for example, hit entity was and wall normal, those used to be defined up at the top, and now they're going to be defined here because they actually, this is where they actually get used, like so on. And so that just allows us to take whichever one of those we want. Now we haven't filled in these two ifs here. We're going to have to do that. I guess we're going to have to do that right away. Let's just do this for now. There we go. So it looks like we're compiling fine. We just need these actual tests. So this one right here, we have to test for overlap. And this one right here, we have to test to see whether the entity is an empty space entity. And so we have a way, very trivially, to test if it's an empty space entity. It just is whether or not this traversable flag is set. So basically, if this test entity has the traversable flag set, then we know we're doing basically a maximum extents movement test, right? And then what we want to do is, before we test against this guy, we have to verify that you were actually inside him, right? You have to have been inside the bounding box in order to do the move. And so what we want to do is sort of take our overlap testing that we were doing here. We want that overlap testing to occur inside the loop. And what's interesting about that is this is actually something that we probably should have been doing in the loop anyway, where we are handling the overlap in a more intelligent way. So it's kind of something that probably is good for us to have been doing regardless. And we do have a little bit of an oddity there, which is that we kind of want all of the things that you're overlapping at any given time to have an effect on you. And again, this is just, you know, the complexity of really doing motion correctly in games is it's very, very complicated. As you've seen so far, we've spent a bunch of time on it, way more time than we spend on a lot of different things that we had to spec out. But I don't really want to stop pushing on a lot of these things, because usually what happens in any particular piece of code, especially when you're working on something that's relatively complicated, is things get very complex, and then you start to find ways in which they can simplify down, right? And so, you know, sometimes proliferating out and really like handling all the edge cases and thinking it through and improving the capabilities of something, even though that ends up with this big, messy nightmare in some cases, that's actually not something to be too afraid of, as long as you are then willing to go through and go, all right, now that we've seen the nightmare, how do we turn it into a pleasant dream, right? And so that's what, you know, happens a lot of times in code if you push through it. And so I would encourage people not to be scared about how ugly some of this stuff is to handle, and, you know, don't just go, oh, let's just go do something simpler, because a lot of times in the end what we come up with might actually be quite simple. Like, we may be able to then reduce down, and end up with something that is actually pretty simple in the end. But it took us that sort of circuitous route to get there, because we have to see all the complexity first before we can have the insights that make things simpler. And we've seen that happen already on the stream a couple times in other places. So that's why I would always encourage you to push through that. Do go solve the problems, no matter how janky your solutions end up being, because once you have them all solved, that puts you in a really good position to come up with more clever, streamlined solutions that still get all the benefits, that you're at a perfect point to be able to do that once you've seen it all, right? And before you've actually gone and solved them all, you don't really have the necessary sort of perspective and of how everything really works in practice. So yeah. So what we want to do here is take a look at, let's take a little step back and just think about that overlapping bit just a little bit. So as we go through our iterations on each iteration, right, we are doing this overlap testing, and we're seeing, we've got, what entities are we inside, right? What space filling entities are we enclosed by at any given time? And those entities that we are enclosed in, we want to take a look at those sort of, how should I say this? We want to take a look at those in sort of also a, so as I think about this more, I'm thinking maybe you don't want to double up that notion though. Like maybe we don't ever really want to say that something that encloses a space can also be a trigger. We may want those to actually be separate because they mean different things. So I guess I'll put that aside for now. I guess really all we do need to do is just pull out, oops, what did I do? Did I hit? No, I didn't. All right, we're fine. I guess really all we do need to do is pull out the notion of the overlap test into something else so that we don't have to do it multiple times. So basically this stuff right here, this testing, that's something that we probably want to loft out. So let's go ahead and nerf this for 1 second so that I can pull out the other test and verify it well enough. So let's go ahead and do that. So let's end if this. We'll go back in here and just say, so the, oops, that's no good. What did I do wrong there? I managed to make it, oh, right. With our tmin set to zero, tmax set to 0, you'll never be able to move anywhere. So temporarily, I need to set this tmax to 1 so that you can actually move, right? There we go. So this is the thing that's doing that actually operates on overlap right now. Is that moving up and down? So I want to go ahead and do the overlap test to make the overlap test be better. And so let's go ahead and do that overlap test because it's got a to-do on here that says handle multi-volumes. Let's handle the multi-volumes and then pull it out into its own test that allows you to check for overlap really easily, right? So in order to check for overlap, what we want to do here is move this entity rect inside so that what we're going to do is we loop over the volumes of both things like we were doing before in another one of these double loops, right? It's literally this thing right here, this loop right here, so we could just reuse that, that verbiage. That is sort of the way in which we were doing that testing. So what we want to do is test the, what are our two things here? There's test entity, so it's exactly the same as it was before. So we've got the two different entities, we now have the two different volumes, and so what we want to do is make this code happen, and then at the end we say if overlapped, we handle that overlap, right? So we'll basically say bool overlapped equals false, and we can early out as soon as we know that we overlapped because we don't need to keep checking for overlap. So what we want to do is say, if we aren't overlapped in each of these loops, then we'll do that. And that way, when we set overlap to true, here, it'll break out of both loops and be done. So here we are inside our volume testing. We can do it exactly the way that we were doing it before, right? Instead of doing total volume in both cases, all we really have to do is switch to using the two different volumes that we said. So we essentially have entity volume, I believe. What is it? No, it's just volume. So we have volume, like so. Right? Oops. So we have volume, and then we've got the test entity rect is going to be the test volume. There we go. And now we are looping over both volumes and testing them both. and then we are seeing whether or not those volumes intersect. And we can actually do it just straight ahead, since we know we break out immediately upon overlap being true. We can make it a little bit more concise, so there we go. So now we've got a relatively concise overlap check that we're doing here. And so what we should be able to do is now pull this out into its own function, right? So let's go ahead and compile that first, make sure this works okay. Bool 32 volume forcing value to true. Oops, I typed that wrong. And by the way, this is why I hate bool and always type bool 32. I don't like these warnings, right? I don't want the compiler to do those quote-unquote optimizations there, or lack of optimizations, to do those things that turn things into 0 and 1 for no reason. So I just want everything to pass through regardless of how it was computed. So, all right, now we've got that. Let's pull it out, although I guess I'll test it first just to make sure that it still works. It does, so that's good. And we can go in here and pull that out into some kind of a function like internal bool 32, entities overlap. Sorry, I was thinking about some things in my head. So I might want to do something else here, which is introduce a little... Okay, so I had a thought, and I'll share that thought with you in one moment. So let's go ahead and pull this out first before I share that thought with you. So let's say, okay, we've got entities overlap. What we want to do here is pass in the two entities. So we have an entity and a test entity, right? And maybe I'll upgrade the nomenclature of this a little bit as well. So we'll call this result equals false, and we'll just do this result, 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 and then return result, right? Oops, sim region. So overlapped. This will now just be if entities overlap, and it'll pass the two entities in, like so. And again, this is classic compression-oriented programming here, right? I'm just looking at things, pulling them out when I know I want to use them multiple times, and letting that guide the design of everything, right? I'm not thinking about the design at all. I'm letting literally the reuse, what I want to call at any given time, drives that sort of upward motion. I really like that style of programming. I find that it works really well. Even early in the morning like this. So now this is much simpler and easier to read as well. We can even sort of double this up. We can almost just say this, right? Like so, and that just makes this loop really nice and pretty simple. We now handle multi-volumes, so that's pretty good. And I don't know what we want to do about this. We'll still leave that as a to-do for a little bit later on. So this looks pretty good here. What I was going to say is I wonder if what we want to do is move our epsilon into here so we can say that there is an epsilon, basically a enlargement region, if you will, in terms of testing whether these overlap. And I feel like we could even say that there was an epsilon in all three dimensions. I know it's a little bit weird, but this is just a thought I was having. And so by default, if you ask if they overlap, there is no epsilon, but later we could make there be one, right? And it's really easy for us to do because all we have to do is take one of the volumes that we're using for the overlap test and add the epsilon to it, right? And that enlarges that guy by a little bit, which means that there's now some sort of fudge in the overlap. There's a kind of an extra boundary there, right? And the reason that I think that's kind of interesting was because that would allow us to do that sort of the overlap to be a little bit forgiving in those things you're allowed to move through, so that we can do precise stopping on those room boundary guys, we can do precise stopping on them, but we can also figure out which one you're inside much more easily. And so I kind of like that idea. I'm going to go ahead and stick with that for now. And so what we would do in here now is we'd re-enable this guy, like so. And we can set this to basically entities overlap. And what we'll do there is pass entity and test entity like we were doing before. And assuming that the two entities overlap, then we actually will use that Tmax to see what the furthest we can go is inside that entity. Now what I wanted to do here is, again, use that enlargement region. And so what I'll probably do is say, okay, we have our overlap epsilon, right? In fact, I'll just say overlap epsilon. The overlap epsilon will be something fairly small for now. Probably, I don't know exactly what it should be. This is definitely something we'll have to look at in more detail later. But basically, we'll just have, we could even do this. You might want to make a utility function for that. Something that just spams one value out to all of the things in a vector. But so, all right, that does the overlap test. There we go, missing a parentheses. That does the overlap test and allows us to make this loop properly. In theory now, oops. I really need a better typing setup here. I'm always find myself askew in the way that I'm kind of crammed in here at this desk. All right. In theory, now we could actually, well, no, that's not good at all. We never seem to be able to get past our Tmax. What's wrong? All right, so now it's time to debug this. I was hoping that might just work, but of course, it never does. So let's take a look at what's going on here. Just spot check before we go debug this, make sure we didn't do anything obviously stupid. So when we're doing our Tmax test, we need to set our Tmax test to 0. We assume that that's the minimum you could possibly move. In fact, these, I guess, are technically Tmax test, Tmin test. These don't really need to be out here. And neither does hit this. Right? These are actually internal things. So these are actually like here, right? And down here. Like so. And this one doesn't have a Tmax test, and this one doesn't have a Tmin test, right? So yeah, in fact, and I'm going to move over here to this side so that my head is not constantly in the way. So when we come through here and we do these tests, we're testing to see, we're accepting the largest value, it looks like, which is what we wanted. So I'm not sure what the problem is exactly here. It could be that our entities overlap call is not working properly. I guess we do have another thing that's kind of stupid, which is that, we actually probably, since we're already looping over the two volumes, that loop, those volume loops, are really set up wrong. Now that I think about it, right? We don't actually need to loop over. We don't actually need to loop over the volumes. So just thinking this through, right? So up at the top here, and in fact, I guess this can collide is exactly probably why we're not getting in here. So I didn't really think this through enough as I need to. Basically, this can collide is really something to be done as an internal check, and furthermore, the entities overlap check doesn't need to be done per volume like this, right? The entities overlap check can be done once for the entities up at the top. And so really this loop, this can be done all the way out here, right? This is actually being done up here. So let's reorganize this a little bit. That's being done up there, and this part right here looks a little bit more like its partner there. And similarly, this can collide, right, is part of this check here too, right? So essentially what we need to do is out at the top here, we need to do that determination of whether or not this is something worth considering, and then traversable tells us which one we're going to do on it. So in some sense, we have something that's sort of like, if it's traversable and the entities overlap, right, then that's one reason we might do it, or if you can collide, right? And so I think the test we actually want to do is out at the top here, we want to say, if it's a traversable entity, right, and the entities overlap, then we would do our collision processing. Or if there are things that can collide with each other, then we would do our collision processing. And those are the two reasons that we might start checking the volumes, right? But otherwise, we wouldn't do that. And we got to do our epsilon up here, right? So that is really the loop that we wanted, I think, or at least closer to it. And then the rest of this stuff does what it does, right? That seems a little more sane to me. So let's take a look. And now we're actually working a little more properly. But we don't really have any places right now that we can test against our blue line. So what I'm going to do is I'm going to go back here to our thing that creates the world, right? Here's handmade.cpp. And when we do add wall, I'm just going to go ahead and say that we're just not going to add walls. We're not going to add walls to rooms past the first room, right? So basically, if we have screen index here, I'm just going to get rid of those walls everywhere else. So I'm going to do if screen index equals 0, we add walls, otherwise we don't add any walls. And so that means that we should have a world that pretty much only has those walls at the beginning, right? So there's the walls, and we are colliding with them. That's good. We're colliding with all the other people here and so on. And then we kind of walk up here, and now we're in a place that doesn't have any walls, right? And so we're walking around, and so let's make sure that we can't go outside of our blue line. And we can't, which is what we wanted. That's a good thing. It looks pretty solid at the moment. Although we do have, there's some stickiness that I don't like. I'm not sure why we're getting, and that feels like we're able to do some things I don't think we should be able to do. So yeah, we're getting some stickiness there, right? We're sticking. And I believe that sticking is probably because of the way that we're doing that epsilon handling. We're not, you're allowed to go, because we're not setting you inset from the space on the epsilon, our sliding stuff is a little bit more broken. Let's verify that that's actually the case, and we'll have to think about how we want to handle that. We really don't want those epsilons in there anyway. So, you know, that's something that's definitely on my radar of stuff that we want to clean up, but I don't have a really good idea of how we want to do it yet. So that's going to have to be something we set aside some time to think it through and do something nice with it. But basically, it's this part right here, you know, where we basically want to say this exact thing that we were saying before. We would still need to do it for the other side. And now, you know, we get that sliding, which is what we want. So, you know, I would consider this a bit of a success. I think this came out relatively well. It's doing what we want it to do, which is preventing you from ever getting outside. And I like that. And so that's a good start. That's a pretty good start, I think. Now, I'm not sure why we're stopping in here, though. That's a bit odd. I wonder if that's just because, what is that T epsilon? The T epsilon is the same as our overlap epsilon, which is not what we would want, right? We'd have to make those be different in order for this to work, for you to be able to cross through these properly, right? Although I'm not sure why. It seems odd, right? I'm not sure why we can't cross over that boundary. That's definitely a bit janky. Because I can go through that boundary I could go through that boundary in one direction, but not the other direction. All right, so we definitely have some bugness there. Something they'll have to think through. Take the stairs. Is this a stairwell? Is the stairwell up or down? Stairwell down. So yeah, so why can we not... That's interesting. It's the same. We can't go backwards. I wonder if that's just an order dependency thing too. So if we have a bug and it's just the order in which these two things were added, you can go from an earlier entity to a later entity, but not vice versa. You know what I mean? I'm not sure why that would be though, because since we're taking the maximum hit, is it just an is it because, is there something weird about the way this overlap works? Like you would think, we must just have a simple bug actually, because you would think, especially if, so we're in the situation, it should repro right here, right? Yeah. You would think that if I made the overlap test very permissive, so I said like, oh yeah, the overlap epsilon is massive, right? That now we would definitely be able to pass through there because it should find that we are enclosed in that other guy and his Tmax should be very large. So the question is, with that overlap epsilon very large, why is it not possible to find a larger Tmax there? And I don't know the answer to that question. It's very strange, right? And so when we come in here and we're looking through these walls, we find whatever our Tmax test is less than whatever the result is for this particular wall. We then accept it. Yeah, I don't know. That doesn't seem logical to me. So I guess what we need to do is step through this and see what's going on here, because I don't have it, and maybe it's just the early morning stream. Maybe it should actually be obvious what's going on, and I'm just not seeing it. That seems like probably a pretty likely thing for sleepy time programming. And we've got about 7 minutes left, so I think we've got some time to step through here and see what's going on. So let's take a look at pushing forwards through there. So I'm going to go ahead and do this Tmax test. Let's see what's our yeah. So I don't know if this will be the best test because, of course, I think our Tmin and Tmax might already be small, but I'm not sure about that. Yeah, okay. So anyway, we have our Tmin and our Tmax. We're coming through here to test these wall normals. This is somebody that we're already inside. And so let's take a look. What is our T result equal to? Okay, our T result is massive, which is fine. So we accept it, and our Tmax test is very large. We don't have any other collisions with that, and so that's fine. We accept that as our new Tmax, and off we go. And we've set our hit entity. Right, we come through here. Is that the only one we're going to? No, we're going to test against another one, so that's good. Off we go. So now we're testing against a separate one, so resetting a Tmax test to 0 again. And now we find a much closer hit. So in theory, that will get accepted as Tmax test now, right? But we should ignore that hit, I would think. Oh, no. Oh, yeah, that's it right there. This has to get initialized to what our current max is. That was dumb. Yeah, so that's the problem, right? We weren't initializing it to the best one we'd found so far, so it just happened to be whichever one was next. Yeah, so then those are fine. And I'm not sure if we really need to have that permissive overlap test anymore, but let's double check and see. I'm just curious. Yeah, so that passes through properly now and still stops in the boundary. So that seems pretty good, but you know, It's still a little janky, certainly, to say the least, but we're definitely getting there. All right, so that's pretty good. And so these now serve as boundaries properly. And so the next thing that we will want to do, and I don't think I want to start this today, this will be next week's thing, is to actually start playing with Z levels now. Because now we can go ahead and do our sort of testing against these to drop us down to wherever the floor would be. And that's pretty, that's going to be a pretty significant code change as well. And so now that we've got this working for the most part, I think we want to kind of stop and go ahead and move into the Q&A. So that's pretty good. I think we made pretty good progress there. Yeah, so let's do that. Let's go ahead and do the Q&A. Yeah. What's our situation here? So it looks like this, I think, is already handled. This we need to play around with next week, and these two were pretty. We're on the edge of solving these two. So I think we might, if we're really lucky, we might be able to knock off this entire thing next week. Although next week might have to be short because I do have a business trip Monday and Tuesday that may make it so it's hard for me to stream on those 2 days. So maybe not. So it might take us till into the next week because we're going to lose some days. But we're getting pretty good on this, right? So that's pretty good, yeah. I feel like debug code is a real easy one. This is going to be pretty trivial. It's pretty rote, so there won't be a lot of fussing. There's a bunch of code to write, but it's pretty trivial. This one is as well. So these will be pretty easy ones. So we won't probably get to the next hard stuff will be coming through here. So we're basically going to have two pretty easy guys here and here. Yeah. So I wonder if we want to sort of break this up a little bit. I guess we'll see what we feel like doing. But since debug code's going to be kind of a fast one, maybe we want to do something more like that, where we do like this, because this is a little more interesting and involved of a topic, and then do audio, then come out to metagame, and then kick it through. Yeah, seems reasonable. I'm excited about this. So many good things to do. So yeah, we're really pushing through. The hardest stuff is really front-loaded. Collision detection is going to be probably one of the nastiest things that we're dealing with. So yeah, this will be a good block to get done. This is a really hard block. Easy block. This actually block isn't that hard either, but it's stuff that people do weirdly, so it'll be something they'll have to kind of cover, like here's why you do it this way, and this has some nice benefits or whatever. And then yeah, audio is pretty trivial as well. So yeah. All right, Q&A time. Let's go ahead and do some Q&A. Can you explain the length of array macro and the size of pointers? So this seems to come up a lot, and so I feel like this is something that's unusual for people, or I guess I don't know, like it just feels like some people have trouble with these. They're like, maybe they're not things that they're used to seeing, and so maybe like let's explain this like very slowly and be very clear about what's going on, just so everyone is sort of on board with it a little more cleanly. So the idea here is that in C, oftentimes I find myself wanting to define an array, right? And so you can see that I do that sometimes here, right? Where for whatever reason, it might only be temporary or it might be permanent depending on what I'm doing. I want to define an array of things. And like in the case of mouse buttons, if we only know that there's always 5 button mice and we're never going to handle more of them, it'd be stupid for us to go ahead and make some kind of flexible sized array and incur the overhead that implies, when we could just compile the code to know exactly how many mouse buttons there were, right? So I find myself oftentimes wanting to make arrays that are of a fixed size. But I don't really want to write the code to assume that fixed size baked into it. I would rather have the compiler do that so that if I do in the future decide that I want to change it for some reason, it doesn't necessarily have to change at runtime, but it might have to change at compile time. So I define the array to be whatever size it is, and then I want to write the code being able to use that number. Now, one way to do that is to use a pound define for whatever the number is. But the problem is that can break, right? If I pound define something and then later I change, I accidentally use the wrong pound define in the code or something, or I change which one is being used for the array size, now the code that was based on that pound define is mismatched with the array. So what I'd rather do is be able to look at the code and know that it's actually using the size of the thing that's actually talking about. And so that's why I use this array count macro, which allows me to pass the array that I'm working with and directly compute its size without having to rely on some kind of pound define. So it doesn't matter how the person defined the array, this will compute it. And so how does this macro work? Well, in C, there is this concept of the size of it's a compile time directive, really. It's not actually a function. It looks like a function, but it doesn't call anything. What it is it's a question to the compiler that says, I'm going to pass you a value. And what I want you to do is, instead of looking at the actual value, what's in the value, instead of what's contained in this name, like you would normally do with a variable, like if I say foo, normally, if I say int foo, normally I'm talking about what's contained in the int when I say foo to the compiler. In this case, don't think about what it stores, think about how big it is. How big do you think int foo is? And it replaces that, when you ask that, with that size in bytes. So when I say size of int foo, I get back 4, right, on a thing where integers are 4 bytes long, such as our platform right now. Now I can pass more complicated things to it. So if I have an array like int foo 5, when I ask for the size of that, it will actually tell me 5 times the size of an integer, which is 4, or 20. So I can ask for the entire size of an array and get it back. The problem is that doesn't tell me how many elements are in the array. It tells me how big the total array is. So if I want to know how many elements are actually in the array, I need to know how big the elements of the array are and divide by that number, right? So in this case, I'm going to say size of foo and it's going to give me back 20. If I know that an integer is 4 bytes long, if I divide by 4, I get back the original 5. That's the number that I actually wanted. And so what this second size of does is it says, what is the size of the first element of that array? Because that's how big every element's going to be. The elements can't be different sizes. And so by writing the macro this way, it allows you to take the name of an array and produce its count directly by just looking at the total size of the array divided by the size of its first element. That gives me how many elements there are, right? Now, the reason that I can't call that directly for the thing that I believe the person was talking about here, the reason that I can't call that directly on this is because C doesn't have a way for you to basically do this. Right? There's no way to say how big is this array in some other type, right? Now you can do that now by using declval, which we mentioned the other day. That's a brand new feature that got implemented or whatever. So I still use the old school way because it would work. It works everywhere and doesn't require a new feature. So no sense needing to use the new feature if you don't have to in some sense. So since you can't do this, what you do is you pretend that you would have an actual value, because size of needs to pass values. You can't give it types. You can't give it members, right? If that makes sense. So if you say size of, you can't pass it the member of a struct. You could pass it a type just like int, and you could pass it a type like game input and how big that is. But you can't ask, you can't ask for just one member. Now, why? I have no idea. It makes no sense to me that you can't do that, but you can't. So since you can't actually do that, what I'm doing here is pretending that I have a pointer to something and asking how big the controller's thing would have been off of that pointer. Because we know we can always say like size of some value that I might have, like camera P in this case, right? I know that I could say if I had a world position camera P, I could ask for what the size of that was. So what I'm doing is saying pretend I just have a value which, you know, I don't have an actual pointer to a game init struct, but I can cast 0 to it for free, right? Pretend I had that, how big would it be? Since C will never actually evaluate this instruction, it's never this expression, it's never going to evaluate the actual value of the expression. So I don't have to worry about dereferencing the null pointer because it's never going to look at the value. It's just going to look at the type, because what sizeof does is it says, what is the type of the thing on the inside? So since it only needs to look at the type, it says, okay, well, what's the type of a pointer to a game input, and looking off that at its controller's member, what's the type of that, right? It's going to go look and say, oh, well, I know what the type of that is, right? The type of that is, I'm going to go look up at the struct game input, right? I'm going to look here. I'm going to look for controllers. I'm going to see what the type of that is. Game controller input. Okay, that's the type. So it will never actually dereference that null pointer. It's strictly constructing a synthetic value that has the right type, because that's what C allows you to do, right? And C++ up until very recently. So that's, you know, that's how that works. I don't know why I've still got changes here. Undo, undo, undo back to the beginning, please. There we go. All right. So that's all that's going on there. Hopefully that makes some sense. Will the space entities be used for the collision optimization you were talking about in an earlier stream? ON squared stuff. Probably not. They aren't super suited to that because they're more about defining the locations of things. So we could choose to do that, but if we did, we'd probably break those up more. And that's not a bad idea. Like the way that we could envision the structure of the world is we could start thinking about, instead of having those spatial things be entities, they could be sort of a superstructure that gets divided up and is used as a spatial partition. We could go that route. So I don't know, but we probably wouldn't use them. If we did go that route, they wouldn't be entities anymore. They'd be a special purpose kind of a structure, I think. But that's totally fine. And someone's saying size of game input controllers works for you with G++. That may be because that's a valid extension in G++. G++ has a lot of logical extensions. It should have been something that they allow in C, but of course you can't actually do it in regular C++, right? You know what I'm saying? So that's just the way it goes. But GNU C++ has extensions, and some of those extensions are good. That would be a good one. I think that should have worked, right? I think that should have been how sizeof worked. It just unfortunately doesn't. I noticed that you tend to mostly skip over questions past the first question mark. Is it because you just parse that way, or the rest tends to not be much interesting? Well, I see the whole question. Well, what my parser does is it pulls out the question, the IRC line from Q colon through to the end of the line. So that means that as long as the question fits in one IRC comment, I see the whole thing. If it's too long, I won't see the second part. So that sometimes happens. But in general, no, I read the whole question and then just answer the part that I think is interesting to answer. But sometimes I also just forget to look back and answer the second part. If my answer kind of goes kind of long, I might just forget. So it could just be me being forgetful. I may have seen it and then forgot. But yeah. For things like the projectiles, are we going to extend their bounding boxes in the z-axis so they will always hit enemies that are below them, or are we going to handle that in screen space somehow? So I think that'll depend on whether we want bullets, style things to be able to fly over or under entities. Like, I'm not sure is the answer to that. That'll be a gameplay concern when we actually are in there playing it a little more and seeing what we like about that. So yeah. And speaking of that, I should add a note to fix that bug we have with projectiles. fix sword collisions. So when we're cleaning up our predicates, I suspect our predicates are set wrong now, and the predicates are kind of a mess right now, so when we go to do that cleanup, I'd like to fix the swords as well. Do you dislike templates? Yes, I do dislike templates. And I've talked about this a couple times before. Really, the short answer, so I don't have to rehash it again, is just I don't like templates because I really like metaprogramming, and I feel like templates are so bad at it that I just get frustrated if I ever try to use them. I'm like, these are awful. Like, everything that you might want to do is done in the worst possible way, you know? And so I probably wouldn't be so angry at templates if it weren't for the fact that I actually really like metaprogramming, and I'm like, seriously, guys? This is the way you did it? So it really just gets me angry because I'm like, okay, it's clear that whoever made templates has no idea how to metaprogram. Like, they were just like, they'd never done it before, they don't understand it, they were thinking of it from a very abstract, not the perspective of someone who ships software using metaprogramming. They were coming in at it from some weird like language design thing which is never a good place to start. And so I just get frustrated and angry, and I'm like, and so I don't use them anymore, pretty much at all. Because of that. How will you handle something like an explosion that affects all things in an area? Then it's not one entity colliding with another. No, it is, right? Basically, every time that you handle something, there's no such thing in computers as something affecting a bunch of things simultaneously. You can only operate on two variables at once. That's just the nature of a CPU, basically, right? And so what ends up happening is, even if you have the concept of an entity that's affecting lots of entities, it's still doing it piecewise. So if you do an explosion that's affecting a bunch of entities, you're still looping through each of the entities and having them collide. And so, it would be the same way that it works right now, where you loop over all of the things that the explosion touches and update them individually, right? And as for the person who's asking about what I think about the Vulkan API, again, I've already answered that on a previous stream, not to rehash it, again, the very short answer is they haven't released the API, so I can't actually discuss it in any detail because I haven't had the opportunity to see its actual design. Once I have the API in front of me and I'm able to evaluate it, I will be able to give a better opinion about it. But until then, it's nothing really you can say. So looks like we're at the end. Looks like we're at the end of the questions, which is good because it's right about the end of the stream too. All right. Well, I guess I will wrap things up then. Let's go ahead and close down everything here. Maybe save our mischief. I think I forgot to do that the other day. And so I like it. So the mischief file ends up in the Handmade misc directory. It's blackboard.art. And so I try to save that periodically so that when people download the source code, they can open up the drawings file if they want to. That's the thought anyway. So yeah. All right, let's go ahead and end the stream. That brings us to the end of another episode of Handmade Hero. Thank you very much for joining me this morning, even if it was a bit of a sleepy morning. We did some reasonable coding. It worked out okay. So thank you very much for joining me. It's been a pleasure coding with you, as always, even if we are all a little bit sleepy. If you would like to follow along at home, obviously, like I say, you can pre-order the game on handmadehero.org, and it comes with the source code, so even now, before we've really done much of the game, you can start playing around with it yourself, and learning from the source code, playing around with it, making your own experiments in there, and changing things and see how it works. It's a pretty good way to learn with things. So if you pre-order the game, you get that, and it's updated every night after I'm done coding, so you can follow along with stuff literally as I do it if you'd like to. We also have a Patreon. If you want to support the video series, you can always subscribe to that. Very much appreciated. We also have a news and forum site that's got a bunch of information from the community about Handmade Hero. It's got ports to Mac and Linux. It's got a great annotated episode guide I highly recommend checking out. Just a lot of good stuff on there. So if you're trying to learn from the series, that's definitely the place to go. We also have a tweetbot that tweets the schedule to you. Newly, freshly updated so that it's even daylight savings time aware, ladies and gentlemen. That's how fancy it is. It changes between PST and PDT. No Y2K bugs here, man. So yeah, if you want to know when the stream's going to be and you want to know in advance every day what time the stream's going to air, and also on the weekends it posts schedule for the coming week, so on, that sort of stuff, that's the place to check it out. And you can also follow that bot on Twitter if you want to have it sort of integrated into your feed. So that's it, everyone. I think, speaking of the schedule, I think I may have to do only 3 days next week. It may be just Wednesday, Thursday, Friday, because I will be out of town potentially Monday, Tuesday, depending on how the business trip falls out. So yeah, I would say definitely double check that schedule and take a look at the tweetbot Sunday to figure out when the stream's going to be if you want to catch it, because the first stream may actually be Wednesday next week. That'll probably be the end of the traveling. Again, I traveled last week and I got to travel a little bit more this week, but after that should be pretty clear sailing for a while, and we should be back to being able to do 5 streams a week, no problem. Although people often are very happy when I take a day off because they like to catch up. So you'll have 2 more days potentially next week to catch up, but then after that, probably not for a little while. So anyway, keep an eye on that, and I think probably I will see you next on Wednesday. So until then, have a great weekend, and I will see you next week.